Hello everyone. In this video, I'm going to show you how to balance ionic equation in basic medium. What basic medium is a solution, usually where this reaction happens, where it contains hydroxide ions or OH minus. Okay, so for us to balance ionic equations in basic medium, the steps are similar to the one where I have shown you in the previous video, where we do it in acidic medium. The only difference is that this step is slightly longer. So without further ado, let's focus on this equation right here. So in this equation, this is provided to you in your checkpoint 4.1. This is the additional question number 9. So we have arsenide ion reacting with permanganate ion to produce manganate 2 ion and arserate ion. Okay, so the first step for us to balance these equations is we have to separate these equations. So if we look, the arsenide will become arserate and the permanganate will become manganate ions. So let's have a look. Okay, so the first step that we have to do, as I've mentioned, we separate these two equations. So I'm going to focus on the arsenide ion first to produce arserate, and later I will show you how to balance the equations regarding permanganate ion to produce manganate 2 ion. So we have arsenide ion AsO3 3 minus, and it will produce AsO4 3 minus ions, arserate. Okay, so the first step that we have to do is we have to balance the atoms that is apart from the oxygens. So in this case, it's the arsenic, As. So on the left hand side, we have 1 As atoms, and on the right hand side, we have 1 As atoms. So the number of atoms of As, arsenic, they are balanced. So we can proceed with the next step. And the next step is we have to balance the oxygen atoms. So on the left hand side, we have 3 oxygen atoms, and on the right hand side, we have 4 oxygen atoms. So the left hand side here does not have enough oxygens. It lacks 1 oxygen. So in order for us to balance this, we have to add water molecules. So we add water molecules, and the amount of water molecules that we need to add depends on how many oxygens we need to make it equivalent to the right hand side. So because each water molecule has 1 oxygen atom, so we add 1 to make the total oxygen atoms on the left hand side here to be equals to 4, which is the same as on the right hand side. Okay, so now we proceed to the next step, which is balancing the hydrogen atoms. So on the left hand side, we have 2 hydrogen atoms, and on the right hand side, we have none. So we have to add 2 protons or 2 hydrogen ions. So now the arsenic on the left hand side is the same as the right hand side. The oxygens here, they are 4, which is equals to the right hand side, which is also equals to 4. And on the left hand side, we have 2 hydrogens, and on the right hand side, we have 2 hydrogens. Now, this step here, the next step, is the deviation from the technique to balance redox reaction in acidic medium. So now we have H plus, and remember in basic medium, we do not have H plus ions at all. We have hydroxide ions instead. So what we need to do is we have to manipulate these equations by adding hydroxide ions on both sides of the equations. And the amount of hydroxide ions that we need to add is the same as the amount of protons here that we have added. So we add 2 hydroxide ions here, and we add 2 hydroxide ions here as well. Okay, so now what will happen is these 2 hydroxide and protons will produce 2 H2O. So 2 here, 2 here, produce 2 H2O. So we copy it down again, ASO3, the arsenide, reacting with water plus 2 hydroxide will produce arserate plus 2 H2O. So now this is the additional steps that you have to add in comparison to the balancing redox equations in acidic medium. So now this we can simplify. If we look here on the right hand side, we have 2 water molecules, and on the left hand side we have 1 water molecule. These water molecules, the difference is 1. So we can cancel the terms, and the remainder we leave it on the side that has more water molecule. So this is 2, so we can cancel it. Cancel this. So we will not have water molecules on the left hand side anymore, and we will be left with 1 water molecule. Okay, so I'm just going to copy down the equations again. Okay, and this can be deleted, and okay, so now what we have to balance is we have to make sure that the charges are all balanced, and on the left hand side here we have -3 charges, and here is -2. Each of the hydroxide carries -1 charge, and there are 2 hydroxide ions, so 2 multiplied by -1 is -2, and here we have -3, and this is 0. So we have to add the electrons on the side that is least negative. So if we look here, this is -5, and here is -3. And if we do the number line method again, so draw the number line, -3 and -5. So this -5 right here represents the left hand side, and this -3 right here represents the right hand side, And remember, when we add the electrons, we will always move the number line to the left, so we add it on the right hand side. We have to add 2 electrons, so here we add plus 2 electrons. So now this here, okay, so this right here will be our balanced half equation. And just to make sure, we check, make it a habit for you to check whether it's balanced or not. 1 arsenic on the left hand side, 1 arsenic on the right hand side. There are 5 oxygens, 3 plus 2, 5 oxygens. We have, this is 4, so we have 4 oxygens plus 1, 5 oxygens as well on the right hand side. And we have 2 hydrogens, and the charges here is -3 plus -2, -5, and here is -3 plus -2, -5. So now we can focus on the second half equations. So we can focus on the second half equations, which is between permanganate ion and manganate 2 ion. So okay, so we are given permanganate ion MnO4 minus, and it will produce Mn2 plus ions. So now what we need to do is we have to balance the atoms apart from oxygens. In this case, it's the manganese. There are only one manganese on the left hand side, and there are only one manganese on the right hand side. So we do not have to balance it anymore. So we proceed to the next step, which is balancing the oxygen atoms. On the left hand side, we have 4 oxygen atoms, and on the right hand side, we have none. So we have to add 4 water molecules. And now we can proceed to the next step. The next step, we balance the hydrogen atoms. On the left hand side, we have 4 multiplied by 2, we have 8 hydrogen atoms. And on the left hand side, we have none, which means we have to add 8 protons. Okay, so now all of the atoms are all balanced. And now we proceed with the next step. And remember, we are doing this in basic conditions. So we have to add the same number of protons. We have to add hydroxide ions. And the number of hydroxide ions that we have to add is the same as the protons, which is 8 hydroxide. And we have to do it on both sides. Okay, and we can simplify it. This will produce 8H2O. So I'm just going to copy it down again. That's 4H2O plus 8OH minus. Okay, so what we can do now is we can cancel the repeating terms. On the left hand side, we have 8 water molecules. We have 8 water molecules here, and on the right hand side, we have 4 water molecules. So this can be cancelled, and here this will be left with 4. 8 minus 4 equals to 4. So now I'm just going to copy this down. Okay. So this is 4H2O, and this here can be cancelled out. Okay, so now what we need to do is we must balance the charges. On the left hand side, we have -1 plus 4 multiplied by 0, 0, and this is +2, and this is -8. If we add it up, this one is -1, this one is -6. So we have to add electrons on the side that is least negative. So again, we do the number line. So this is -6, this is -1. So this -6 represents the right hand side, and -1 here represents the left hand side. So we have to add electrons on the left hand side, and we have to add 5 electrons. So we add here 5 electrons. Okay, so now we are left with these equations right here, and we check it again. There's 1 manganese on the left hand side, 1 manganese on the right hand side. There are 4 plus 4, 8 oxygens on the left hand side. We have 8 oxygens on the left hand side, and then we have 4 times 2, 8 hydrogens on the left hand side, and we have 8 times by 1, 8 hydrogens on the right hand side. So all the atoms are balanced, and we look at the charges. Here is -6, Oh, I'm sorry, I've made a mistake here. We add it on the left hand side, so the electrons should be here. 5 electrons. Okay, so we must check the charges again. So here is -1, -5. So this is -6. And here +2 on the right hand side, +2 plus -8, -6. And as you can see, this is why it's important for us to check the charges again before we combine the equations. Just to make sure, because like everyone is human, we make mistakes. Sometimes we oversee this. It's a typical mistakes that everyone will do at some point. So make sure you check it again. Okay, so now this is balanced. This equations is balanced, this half equations. And this half equations is also balanced. So now I'm just going to copy this down before we combine them. Okay, so these are the two equations that we're left with. Just gonna use. Okay, so this is the oxidation half reaction. Oxidation. And how do we know this? It's because in this reaction we release electrons. We release the electrons here on the product side. And the bottom part is this is the reduction half equation. Reduction half equation. Okay. So what we need to do now is we want to combine these equations together. We have to remember that redox reaction occurs together. So the electrons released in these equations, in these oxidation half reactions, will be used in the half equations of the reduction part of the overall reactions. So the number of electrons released here has to be the same as the number of electrons needed here. So what we can do is we have to find the lowest common multiple of the electrons. And in this case, it's between 2 and 5. So the lowest common multiple is 10. So we have to multiply a number here. We have to multiply a number to make the electrons becomes 10. So we multiply by 5. And then on the bottom part, we have to multiply it to make it a 10. We have to multiply it by 2. So we will be left with 5 arsenite, 3 minus, plus 10 OH minus. I make sure in this case I add a bit of gap in between 10 and OH just so that we are not going to be confused. And it will produce 5 arserate ions. Oops. 5 arserate ions plus 5 water plus 10 electrons. And on the bottom part, everything is multiplied by 2, so we have 2 permanganate ions. We have 2 multiplied by 4, 8 water, 8 water molecule. And we have 10 electrons. And this will produce 2 manganese 2 plus ions plus 16 OH minus or hydroxide ions. So now we are left with this, and make sure that we notice the repeating terms or repeating species. Okay, so now let's have a look on the top equation here. In this equation we have 10 hydroxide on the left hand side, and on the bottom equations we have 16 hydroxide on the right hand side. So these two terms can be cancelled out. So I'm going to cancel this 10 and cancel this. So 16 minus 10, so we will be left with 10, sorry, we will be left with 6 hydroxide ions. And then we have 8 water molecules on the left hand side here. And we have 5 water molecules on the right hand side here. So this can be cancelled as well. Cancelling this, and this will be left with 3 water molecules. And then the electrons are the same, so they can be cancelled out. And this will be the final answer. So bring the terms together, 5As O3 3 minus plus 2 permanganate ion plus 3H2O, and I will produce 5 arcerate ions plus 2 Mn2 plus ions plus 6 hydroxide ions. Excuse me. Okay, so this is the final equations, and again, before we leave this as a final answer, make sure we do the left hand side, right hand side analysis. So I'm going to do the left hand side, right hand side analysis right here. So the left hand side, the right hand side. Okay. So we count the total number of atoms on the left hand side and the right hand side, and also the charges. So on the left hand side we have arsenic atoms, oxygen atoms, manganese atoms, and hydrogen atoms. And on the right hand side it's the same as well. If it's not the same, then it means that you have done something wrong with the equations, with the balancing. So on the left hand side we have 5 arsenic, 5, and on the right hand side we have 5 arsenic as well, 5. On the left hand side we have 5 multiplied by 3 oxygen atoms, which is equals to 15, plus 2 multiplied by 4, which is equals to 8, so 15 plus 8 plus 3. So we have a total of 26 oxygen atoms. And then on the right hand side we have 5 multiplied by 4 plus 6 oxygen atoms, which is also equals to 26. The manganese atoms on the left hand side, there are 2. And on the right hand side we have 2 as well. And then on the left hand side we have 3 times by 2, 6 hydrogen atoms. And on the right hand side we have 6 hydrogen atoms here as well. Okay, so the atoms are all balanced. Now let's have a look at the charges. So the charges on the left hand side is equals to 5 multiplied by negative 3, 5 multiplied by negative 3, plus 2 here multiplied by negative 1, plus 3 multiplied by 0 from the water. So you will be left with 5 times by negative 3 plus 2 multiplied by negative 1, negative 17 on the left hand side. And on the right hand side right here, it's equals to 5 multiplied by negative 3, as you can see here, 5 multiplied by negative 3 for the whole ion, plus 2 multiplied by positive 2, plus 6 multiplied by negative 1. And this should be equals to negative 17 as well. So now if we look, the atoms are all balanced and the charges are both balanced as well, which means that this right here is our final balanced redox reaction equation. And remember that these two are important to be shown. It's important for you to show this in order for you to recheck and find mistakes if you haven't done so. And it's very important as well, just a reminder before I end this video, it's very important for you to do this work neatly, because if you don't do it neatly, it's very hard for you to keep track of the changes that you have made. And I have seen students that have done this poorly. It's not because they don't know how to do this, it's because they did not manage their equations neatly like this. Then they make silly mistakes, they make careless mistakes as well. So make sure to do your work neatly and easy for your teacher or your lecturers to check. And with that said, I end this video right here. Thank you very much for watching. And if you have any comments or any questions, please leave a comment on my video. Or you can also, for my students, you can also comment on Google Classroom as well. And anything can be discussed over there. Thank you very much.